Artistic glass, fiscal year 2018, second project. The project was developing a technique to process a specialty glass. What is a specialty glass? Any glass that they are not a standard flat glass that you see in a typical doors and windows. One of the good example is this glass, this sample that you see on the picture. As you can see, the surface is texture, is not even. In some area, because it's texture, there is a high point and low point. The difference between high point and low point can represent easy to 50% of the glass thickness. And glasses come with various thicknesses, anywhere from 3 mil up to 20 mil. Let's go to the next picture so you can get a better idea what are we talking about the texture. Here we go. I'm zooming so you can get a better idea. Pay attention. Here is really coarse, rough area. Next picture, take a look here. Another one. The problem that I had here is when you are processing this type of texture glass, or let's take one step back. When you're processing a conventional glass, basically a knife comes, say hypothetically speaking, this is a conventional, knife comes and apply an even force while it's cutting it. So this is a conventional method. Well, when you come to the texture, if the knife comes and apply an even pressure, it doesn't work. Simply because where are you going to apply the point of the knife? If it is here and the knife travels coming further up, here is a raised glass in this area. So because apply too much glass can easily break or fracture the glass, doesn't work. Or if you reduce the pressure at this point, hoping when it reaches here, it's going to cut here, it doesn't work because it's not going to cut the top one or the rest of the glass. So the fact that the surface of the glass is uneven creates a major complexity. To make the matter worse is sometimes the cut is going to be in curvature, as you see here, in a radius type format. How are you going to cut that? The best solution that they found was, break it down in a few simpler steps, was using a pattern system. Pattern system basically allows a knife to travel on a certain path, and second, rather than a conventional method that we're using, and second, they score the glass. What is scoring means is, in a conventional glass, when you take a look at it, the knife goes and apply excessive force and basically it cuts it. Whereas in a texture one, the knife comes and creates a tiny cut, and the tiny cut is going to be V-groove type profile. If the V-groove is too much or too much force applied, it creates a micro fracture. And this micro fracture during the separation process is going to create a glass to 2 or 3 or more pieces. One problem. And second problem is right here in this edge and on this edge is a series of chipping issues that they need to prevent. So by using this technique of scoring, they could solve the problem. Pattern and scoring, they could solve the problem. And this allows the applied pressure is going to be variable pressure rather than conventional method of using one uniform pressure. Let's move forward. Here we go. This is a good example. Let's go back one. If the pressure is too much during the scoring process, the groove they created, not only groove is not even, also creating some chipping. Now let me zoom in so you can see. Here we go. Clearly you see the chipping on both sides because uneven pressure. Whereas if the pressure for flat surface is even, you get a nice cut here. Nice fraction, which later can be on the second step of the process can be broken into 2 halves. Again, this is relatively simple type cutting process, become more complex when it is in a radius, which was a part of the objective of this project. Here we go. This is another one. Clearly you see the chipping edges. How you're resolving these chipping edges on the glass. Talking about the curvature. Talking about the curvature. On a textured glass, clearly you see how uneven the surface is. So make it create major complexity. And it becomes even more complex. Again, this one is two-dimensional. When you go to three-dimensional, like a ball type or a sphere type profile. Going back, I'm going to zoom in. Take a look at it. Here we go. This is a cut, radius cut. In this area, the cut is nice and smooth. Here is relatively smooth. In this area is relatively smooth. But here, didn't cut all the way through. Let me zoom in so you can see. You see there's tiny little pieces is sticking out. So to get rid of this one, require additional secondary operation, which increase the cycle time, not to mention adding a layer of health and safety, health hazard toward the operator. As part of the specialty glass, this is another type. Here we go, I'm zooming so you can see. This is a glass, by the way. This is not a bad picture, this is the glass. It's relatively clear, a little bit tinted glass. Inside the glass, I'm gonna zoom in, you can see there's an air pocket. Pay attention. This air pocket can various sizes, various shapes. And compared to this one is relatively giant. Compared to this one, is a small, or this one. Pay attention. So when you have an air pocket, create a major complexity because in air pocket, the wall thickness becomes significantly thinner. And during the cutting process or fabrication process, can easily crack, chip, and create excessive amount of scrap. Problem, again, relative over cutting it, relative is more type, a straightforward process, although there is a complication with this type of antique glass. Problem becomes a lot more complex when you're cutting in a curvature. In a curvature, they found out that rather than cutting it, the best option was, as we discussed, in addition, not only scoring and using the scoring that we talk about it, and using the pattern, rather than cutting it all in one shot, which basically is going to be two pieces, break it down to two and cut every 4 inches, small segments. For bigger, larger one or circular one, they realized that the optimal solution would be having break it down to 6 sections, or roughly every 4.5 inches. So if, say, for example, the curvature is over here trying to cut, every 4 inches is going to be cut. This piece is going to be a scrap. The good piece is going to remain on the other side. Going to the further pictures. Here we go. This is a great picture here. To create a ball or a sphere type glass with texture, the experience that they had to do, they had to develop a mold. The mold that they had, and they put the glass on it, put it inside the oven to basically to melt the glass, to flex the glass, to develop this pattern, this form, which is this one. Create a half ball. It's roughly about 130 degrees angle. The problem they had was with the mold itself. The mold wasn't solid enough, didn't rigidize. So it was easily getting cracked. They had to do a series of investigations, find out what's happening. They realized they can solidify, they can further solidify it by adding rigidizer, is a type of solution to it. That's one. Second, rather than having a soft padding, which initially didn't work, going to extreme using a hard die, metal base, which is not good. Something in between, something relatively firm but not too hard, made of steel, allows the glass to mold, allows the glass to really pass the pressure through the mold to the die without glass getting break or the mold getting cracked. Here we go, as you can see, various type pictures. All the detailed informations are in the interview notes, and always quantify the reports. If you're not sure about the quantification, just put the X mark, highlight it, and I will take care of the rest.